Welcome to YouTube Science Communication. Hi there, my name is Maximus. This is the 64th video that I've made for this class, and today's video is going to be about your position on the tree of life. Let's begin. So the assignment for this video was to watch a playlist about life's history and then make a video using clips from that playlist. What this video is going to be about is the pattern which connects you, a human, to Luca, the last universal common ancestor from which all living things are descended.
Luca isn't the first to have lived. Instead, it's the common ancestor of everything that's alive today.
We'll get to Luca at the end of the video, but for now we're gonna start up here. This whole branch represents our section of the tree of life, and each of these twigs represents lineages that split from ours sometime in the past. We're gonna go through them one by one and watch our ancestors evolve.
Now, we're members of Homo sapiens. Homo is our genus and sapiens is our species.
In the past, there were other members of our genus, like Homo erectus, for example.
Being part of the genus Homo puts you in a pretty exclusive group. It includes only our immediate ancestors and our very closest fossil relatives.
The genus Homo evolved around 4 million years ago, give or take a couple million years. If we go a bit further back, we can find the origins of our family, Hominidae.
Our family is the Hominidae, the hominids, or great apes.
The ancestors of orangutans diverged from our lineage about 13 million years ago. The ancestors of gorillas were next around 10 million years ago, followed by the ancestors of chimpanzees and bonobos around 7 million years ago.
Go even further back and you'll find the common ancestor of all monkeys.
Among the monkeys, you have your New World monkeys and your Old World monkeys. The hominoid lineage split from the one leading to Old World monkeys between 24 and 38 million years ago.
Older still, and you'll find the first primates.
The earliest uncontroversial primates show up about 55.8 million years ago at the start of the Eocene.
As we go further down the tree, we find creatures that kind of look like a cross between monkeys and rodents. They're called Plesiadapiforms, and they evolved around the time that the dinosaurs went extinct 65 million years ago.
Some of the first primate-like species, the Plesiadapiforms. Purgatorius, for example, looks a lot like a rat.
Our earliest true mammalian ancestor is way older than that even, from a group called the Cynodonts about 200 million years ago.
These were the very first true mammals, like Megazostrodon, a tiny nocturnal insectivore that scurried around the feet of the dinosaurs.
Mammals themselves evolved from a group called synapsids, which diverged from the reptiles about 300 million years ago.
Dimetrodon. It lived in the era before the Mesozoic and the Paleozoic. It's not our direct ancestor, but it was a stem mammal, part of the group of animals that descended from reptiles to give rise to mammals.
Reptiles and synapsids share a common ancestor with the first amniote, which laid the first amniotic egg around 340 million years ago, give or take.
Around 340 million years ago, a group of tetrapods called amniotes began laying their eggs with shells that protected them from drying out. And they rapidly split into two major groups, the reptiles and the synapsids.
Earlier still, before the amniotes and the amphibians diverged quite a long time ago, the first tetrapod evolved, descended from a fish that could walk on 4 limbs.
Relatives of lobe-finned fish had adapted to spend more time in the shallows, pulling themselves along muddy shorelines. Then, 397 million years ago, descendants of these critters finally hauled themselves on land for the first time.
All our ancestors which are older than this evolved in the sea. Around 450 million years ago, the lineage that would become us was a group of fish that had just evolved jaws.
Jawed fish like Entelognathus appeared in the seas, equipped with biting power that allowed them to tackle prey that the jawless fish couldn't handle.
But jawed fish are only one kind of fish. The earliest lineage of our fish ancestors can be called ostracoderms, and they evolved 500 million years ago.
The first true fish appear on the scene, ostracoderms, which were jawless and covered in bony plates.
At this early point in the tree of life, even the most basic body plans were not yet fixed. Our first vertebrate ancestors emerged 540 million years ago.
This is the first creature to have the sign of a backbone, and thus, therefore, is probably the ancestor of us all.
They developed the ability to swim under their own power with a flexible rod of cartilage to power their tail. These ancient swimmers would become the ancestors of the vertebrates.
Prior to this point, body plans didn't really exist at all. Our first multicellular ancestor, about 700 million years ago, was probably a sponge.
Sponges are just collections of simple cells that have clumped together and got stuck together.
But we shouldn't underestimate just how remarkable a sponge body is. It's an incredible feat of cooperation. Prior to sponges, all of our ancestors were single-celled creatures, fending for themselves on their own.
Up to this moment, living cells that had been produced by division simply drifted away from one another. But now, some cells were sticking together. Some of these clumps ultimately evolved into animals.
All our ancestors older than this are single-celled eukaryotes, like this amoeba here. But that term single-celled is actually a bit misleading because all eukaryotes, even the unicellular ones, are actually made up of multiple kinds of cells. Before your eukaryotic ancestors evolved, their ancestors came from two distinct lineages called bacteria and archaea. Then, around 2 billion years ago, those two lineages fused, forming the first eukaryotes.
The thinking goes, in the incredibly distant past, some bacteria started living within another larger bacterium. This relationship became symbiotic, where each organism benefited equally from the presence of the other. Over time, the guest and the host in this arrangement became inseparable. They became one living thing.
This fusion is called endosymbiosis, and it's shown on this tree as these two branches coming together at the base. But we have ancestors that are even older than that, going back to the origin of life 3.8 billion years ago.
Darwin himself theorized that such a thing once lived. He called it the primordial form into which life was first breathed. Today, scientists call it the last universal common ancestor, or LUCA.
We don't know much about LUCA, but we know that it used DNA and was bound up by a cell membrane. We know this because all life on Earth, from the tiniest bacteria to you, have these same traits. This tree is a pattern which connects you to every other living thing. We are all descended from the same source. Thanks for watching. This video is part of a class called YouTube Science Communication, where we learn about the history of life on Earth as we learn together how to make videos about it. If you want to learn more about this class, you can check out our Patreon page. There's a lot of info on how you can take it if you want to. And if you want to see more videos like this one, you can click the subscribe button and you will see many more like this. I'll see you in the next one.